Hello and welcome back to Arduino for Amateurs. This is episode number 14, Digital Sound Sensor. So as always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the BitHaven Hackerspace. And what I'm going to be talking about today is using a digital sound sensor as an input for your Arduino circuit. Now, digital as opposed to analog means that we're talking about a sound sensor that can only produce a 1 or a 0. Basically, the sound has either reached a certain threshold or it has not. There are also analog sound sensors. We'll talk about those a little bit more in a future video. But right now I'm starting off with the simpler of the two, the digital sound sensor. What, you may ask, does a digital sound sensor look like? Well, it looks like this. So this is a pretty standard model. There are a few different versions, a few different configurations, but most of them have the same basic components. Right here at the top, this big black circle here, that is a microphone. That is what receives the ambient noise from the environment and converts it into a digital signal, right? Right here, this sort of cross-shaped Phillips head adjuster here, this is how we adjust the sensitivity of our sound sensor. So depending on the environment that you're in, you may want to set the threshold higher or lower for the amount of noise that will trigger your sound sensor. If it's going to be in a fairly noisy environment, you want to set the threshold higher so that that background noise doesn't trip it. Or, if the purpose of your circuit is to do something all the time whenever a room is occupied or whenever there's noise, maybe you want to set the threshold lower, right? It's kind of up to you. It's up to the purpose that you're putting the sensor to. Down here, this little white package here, this is an LED. On this particular model, this lights up red whenever the sound sensor detects noise above the threshold that you've set. So that's useful, again, as sort of a physical layer one. Is my device even noticing that there's noise? Check. At the bottom here, you can see there's 3 pins. As usual, one is for ground, one is for power. So those are marked ground and plus 5 volts. This one in the middle is our output pin, right? So we can plug the 3 of these into a breadboard, or we can use those male to female DuPont wires that we saw in the IR transmitter episode. And we can use that to connect this to our circuit. So let's take a look at the circuit we're going to be using immediately. Once again, I've got my tray here. My Arduino is up at the top in this sort of bumper. Then I've got a breadboard here. This is my sound sensor. I know the angle is a little bit different than it was in the last photo, but you can see right here I've got that black microphone. And then I've got my 3 prongs, right? My ground, my output, and my power. My ground is connected here to the ground rail, to this blue rail on my breadboard, which is grounded back to my Arduino here. I've got the black wire that goes to here. Similarly, I've got the red wire going from 5 volts on my Arduino to the red rail here, where I have a red jumper connecting it to my digital sound sensor. And then in between the two, I've got this orange wire coming down. This is what's connected to my output pin, and that is connected back to pin number 4 on my Arduino, right? So that's really all there is to wiring it. You have to give it power, you have to give it a ground, and you have to have some pin connected to the digital output so that you can monitor that and watch for changes to the value. Over here on this side, we've got our NeoPixel ring. We're not going to use that in this video, but in the next video, we'll talk about how we can use input from our sound sensor to affect what the NeoPixel ring is doing, right? How we can bring together those input and output connections like we have with some of the other projects in these videos. So I'm going to skip over here to my IDE window, and let me grab my device here, and I'll plug it into the computer that I'm recording this on so that we can test it in just a moment. There we go. So the code here is very simple. Again, we're just talking about how to make this work at all. So in the first line, we're setting an integer called sound pin to 4. As you recall from the photo, our sound sensor is connected to pin number 4, so that's all that is. We're just saying that That is the pin that the sound sensor is connected to, the output pin, the middle pin on that sensor. We have another integer named sound counter, and what that's going to do is every time our sensor hears a sound, it's going to increment sound counter by 1. So this will just be our feedback that the sensor is working and that it's detecting noise. We have a Boolean variable. I don't think we've used a Boolean variable in one of these videos before. What Boolean means is true or false, right? So in this case, our Boolean variable, we're calling it soundVal, and we're setting that equal to 0, which is the same as false in the Boolean world. 1 is true, 0 is false. So that's just a variable that we're going to be using later, but we need to declare it here at the top so we can use it throughout the program. Our setup method is very simple. We're setting the mode of sound pin. So the mode for pin number 4 is input. Again, this is one of those pins on the Arduino that can be used for input or output. So we're just saying, yes, we're using it for input. And then we are turning on our serial monitor because that's how we're going to monitor what our sound sensor is doing. Then we go into our loop. Our sound value is set equal to digital read sound pin. So it is going to read pin 4 and determine whether or not it is high or low, true or false. It's going to assign a Boolean value to the value of the sound pin. Now, the way this particular sensor works is if it is triggered, if that red LED is on, if it is detecting sound, then the value of soundVal is set to low. So in that case, if it detects sound, if soundVal is low, we're going to increment sound counter, and then we're going to add 1, we're going to increment sound counter, meaning we're going to add 1, and we're going to print the current value of sound counter to our serial monitor, to our console. Then we're going to delay for 10 milliseconds. You know what? Let's bump that up to 100. And then we go back to the beginning of the loop. So really all we're doing is we're monitoring this sound sensor. If it hears a sound, we increment sound counter, then we print the value of sound counter, then we go back to the beginning. Very, very simple. So let's upload this. We'll turn on our serial monitor. Okay. And if we look here, we see it is already counting up. Now, I am not being especially loud, I don't think, but there is some ambient noise in the room. There's a fan from my laptop. There's a space heater going in the corner because it's February in Buffalo and it's cold. So what I need to do is turn down the sensitivity on this sound sensor. So I'll use my handy Phillips head screwdriver here. I will turn this little Phillips head adjuster, this screw to the left, okay, to the anti-clockwise direction, and you'll see that my numbers have stopped going up, right? So I've adjusted it so that the level of ambient noise in the room, the heater, the laptop fans, the stuff that's already going, is not enough to trigger my sound sensor. I need a louder noise, okay? So I'm going to clear my serial monitor. I'm going to hit the reset button on my Arduino. So I'm doing that now. So that'll reset the value of sound counter to 0. All right. And now if I snap my fingers in front of the microphone, the little red light goes on, but that's not long enough sound to activate it because, again, we're taking sort of a snapshot here and then delaying for 100 milliseconds. So if I don't do it right in that window when the delay is not happening, it's not going to do anything. Fortunately, I have a whistle here. It's a whistle from my friends at BitHaven. I am hoping that my children do not come running when they hear a whistle blowing in my office, but I guess we'll see if they do. And I'm going to blow a short tone on this, and we should see the sound counter value printed down in that serial monitor, okay? See? So sound counter was bumped up to 1, and it printed 1, and then I stopped blowing the whistle, so the digital read went back to high, so it stopped printing sound counter. If I want to do it again, I can do it again. Yep. There we go. And there's value 2. So all I have to do is produce a loud enough noise to pass that threshold that I set with the thumb screw, with the adjusting screw. And if there's a loud enough noise to do that, then my sound pin will switch to a low voltage. It will increment my sound counter, and it will print it to the serial monitor here. Now, this is not super useful on its own, right? This is really just a demonstration of how these sensors work. But in the next video, what I'm going to do is we'll build something with the NeoPixel ring. We'll build sort of a pattern that it can display, and then we will use one of these sound sensors to interact with it and change how it behaves, right? And that's a design principle that we can use for all kinds of projects. Say you want to have a lighting rig that changes color or brightness or some other characteristic based on ambient noise in the room, right? That's very easy to do with these sort of digital sound sensors. Okay? So I hope this was interesting for you, and I'll see you in the next video where we'll do some more cool stuff with digital sound.